Alright, this is problem HRW96P015. It says, the coefficient of static friction between Teflon and scrambled eggs is about, and it gives you a number, I've got 0.03. What is the smallest angle from the horizontal that will cause the eggs to slide across the bottom of a Teflon coated skillet? Okie dokie. We did this for the lab last week, but I'm going to go ahead and just redo the whole thing so that if you forgot the lab or you weren't there, or if you've never done the lab, whatever, then it won't be a problem. So first off, the only thing I know is that mu is 0.03, no units. Now I want to know the smallest angle that will make it slide. Well, I know that when I finally get it slanted, the free body diagram will look like... Wow, that's really, really bad looking. Sorry. Okay, here's the scrambled eggs. I know that gravity's pulling it down. mg. Okay, that's gravity. I know that friction's trying to hold it, keeping it from sliding down the pan. So that's going to be the opposite of which way it would slide, so friction. And I know that there's a normal force between the pan and the eggs. Normal force. Boom. Okay. Basically, I know that, let's see, the normal force and the theta. Okay. I know that the normal force and the part of gravity that's pushing the eggs into the pan, those have to equal out, because I know that the net force in the y direction, okay, well, it has to equal 0. Otherwise, we'd have eggs levitating off the pan or sinking through the pan. That's just not going to happen. So the net force is the normal force up minus this pink thing. So this is mg is the hypotenuse, and then I'm looking for the side that's adjacent to this angle, so it's going to be a cosine theta. Okay, so mg cosine theta, oops, derped. Okay, equals 0. So the normal force equals mg cosine theta. Blah, blah. Okay. That means that since friction is mu times the normal force, that means that the friction force is mu times mg cosine theta. Keep that in mind. Now, if I do Newton's second law for the other side, that is, sorry, the x stuff, net x equals, well, I want the last, basically the angle, the last point where this thing has no acceleration, it's not sliding. So that would be like the largest angle I could get without it sliding. So any angle bigger than that, it would slide. So I'm going to do f net equals 0 as well, f net in the x direction. So this one I've got friction up the slope. So that's friction. And then down the slope, I've got the piece of gravity that is that direction. That's the same as right here. That's the same thing, which is opposite the angle. So this is going to be the hypotenuse and then sine theta. Okay, equals 0. Okay. I'm going to put in, well, f equals this stuff. So I get mu mg cosine theta minus mg sine theta equals 0. Okay. I want to solve for theta, but actually I'm going to solve for mu in this case because it's gonna come out to be a little bit nicer. So if I solve for mu, I want to move this to the other side. So I get mu mg cosine theta equals mg sine theta. If I divide by mg cosine theta, looky, I got rid of m and g. It's gone. So now I have is mu equals sine theta over cosine theta which is the same as tangent theta. Okay, so if I take the inverse tangent of both sides, I'll get the angle all by itself, which is what I want, the smallest angle. Okay, so for my numbers, that would be 0.00 or 0.03. Okay, if I put that in a calculator, I get, sorry, 1.72 degrees. Go check that. Yep, that is what the key says. So that's the answer. We are done.